Well, good day for everyone. Good afternoon for everybody in Latin America, and good morning. Well, not good morning, but good afternoon for everyone that is also here in the West Coast. They are it's just after lunch, I think. So here we have with us Chris Lee. He's a master developer. He works for the IOB family in the RSK Innovation Studio, which is based in San Francisco right now, and he has developed the rWallet. He actually led the team together with Albanzas and some other of our collaborators, the newly launched rWallet. And we will also talk about our updated RSK library or rsk.javascript. So the idea of this workshop and this talk is actually to have a hands-on demonstration, and we'll see a little bit more of code. The idea is to have Chris, who created himself, and also to have him explain all the development of this new technology. As always, this webinar is being recorded, and you can afterwards see it and watch it on demand on our YouTube channel. That it's youtube.com/rsk. And I'll leave obviously the link on the chat box afterwards. And if you have any question, we'll try to answer it back live. And we will also be writing here. I see some of the guys from our team, so we will also be trying to answer it live in written. But Chris will also have a moment like at 10 or 20 minutes for questions and answers. That will be after his presentation is done, and it will take around 30 minutes. So I'm very happy to have you all here. Chris, are you still here? I don't see your webcam on. Did you have any problem with your internet connection?
Let me.
Yes, I'm actually listening to you and seeing you. Perfect.
Okay, you see me.
Yeah.
Okay, cool.
So if you're ready, we can start. I'll be backstage answering you, and if anybody has a question, you can always write it on the chat box or in the questions space. So thank you so much, and here we have Chris with us.
All right, thanks, Fran. Thanks for the introduction. Hi, everyone. As Fran mentioned, today I'm doing this webinar for Rsk3 Gs Library that we built for RSK. So this library, I'll just go straight into the content of my presentation. As Fran has mentioned that if you got any questions, feel free to send in the chat box. Fran will be, writing text, answering the questions. Also, he will be collecting the questions. If your questions are not answered in the chat immediately, we will do another follow-up after the presentation. So let's get started. So the Rsk3 Gs library, the name is very similar to ETH3, Web3. So it's a similar library. It's a JavaScript library API specifically built for rootstock. There are multiple reasons that we chose to go down this path to build this library for our own blockchain. I will mention later in the chapter. But if you have programmed with Web3 before, Web3 GS before, it will be very, very easy, very smooth for you to onboard the Rsk3 Gs library. It just only gets easier. Because I have been a Ethereum developer since 2016. So before 2018, before 2019, we started Rsk3 Gs library. I already had 2.5 years experience using the Web3 GS library. So I know all the goods and bads of Web3 GS library. That's why when we rebuild the new one, Rsk3.js, we try to eliminate the bad. Let's see. It's just getting only simpler. So first of all, what is the main goal for this JavaScript library? If you haven't used Web3 GS before, what is Rsk3 Js? So the main goal for this piece of software is library to serve three kind of people. First is blockchain developers. For example, developers who will interact with the Rootstock blockchain directly. For example, to get the status of the node, to get the node client version, to get the chain ID, to get the block number, to get the block content. For those kind of operation, blockchain developer can use our Rsk3 Gs library. The second type of people we are serving are dApp developers. For example, if you are interested in building a blockchain game on Rootstock, you should use Rsk3 Js. We have all the functions and utilities for the dev developers to build a blockchain dApp. Also very easy. We can see actually the demo today is mainly to serve this category of developers, the dApp developers. We will show you the actual code, just a few pages to get started to build dApps on Rootstock blockchain. Well, the third type of people is whoever is interested. If you're interested, if you're not a developer, you want to learn programming. If you haven't learned blockchain programming, you can check out our demo. On average, I think it's just like 30 lines of code, and you can get started. You can see the status of the blockchain. You can get a balance of a blockchain wallet, and you can send even. So it's just simple. Okay. So far, I don't see any questions. So let's go ahead. Now we're talking about a little more deep in the tech. So technically speaking, what is the R? In my opinion, well, so the original Web3 GS library has a lot of things that I've never used before. I was a dApp developer on Ethereum. I only use 20% of the functions of that library. So today we're talking about the 20% of the most commonly used functionalities. So in my opinion, the core part of Rsk3 Js is first a account holder for blockchain wallets. Well, it's a wallet, but in the code it's called an account. It's like your bank account. What it does is that it manages, like, you can create an account with the library. You can import an account in the library, and the library is just a let's say it's a wallet holder for all your accounts. You can iterate through all your accounts with the library, or you can get a specific one. You can pull it out anytime by one line of code. So that's why I say it's the account holder. Okay, and the second is also, oh, I got disconnected a little bit. Okay, second is also very important. It's called a signer for transactions. For people not familiar with blockchain, what is a signer? Signer means when you write a check, you need to sign your name on the check to validate the check, to activate it. So signing, the signer signing we're talking about today is to make a transaction happen. So basically, you can create a transaction saying, okay, I'm gonna make this transaction. So signing is the process to make the transaction happen. So the Rxk3 Gs library can use your credential, use your secret to sign your transaction, sign any transaction that you created and make it happen. So that's the core part of the, that's the core part for developing dApps on blockchain. And this is the core part of the functionality of Rsk3 Js. The second. The last one, I see it as a collection of utilities. What does that mean? it means that it's a combination of all the required utility developer functions that you will need in development. For example, you need to check, like you get a string, you get address from user input. You want to say, okay, is this address valid? It's right. So this library, Rsk3 Js, can check it for you. And for example, if you want to convert to a hex string, from a decimal number to hex number, this library can do it for you. If you want to convert the small unit, the way to Ether, or the way to RSK unit, R-BTC, this library can do it for you. So it's it's a collection of a lot of utility functions. It's very handy. Basically, during your daily programming, anything you need, you can find it in the utilities. Okay, yeah, that's in my view what is Rx3 Gs technically. Next page. Let me check if we get any questions. Okay, good. Next page is the architecture of Rsk3 Js. This is also technical. It's not 100% of it, but as I said, it's the most important part of it. Let's reviewing the chapter from the last page, account holder, signer, and the utilities. So on this chart, on this diagram, on the left, you can see that the Rsk3 Gs library has 3 accounts. That's the architecture that makes it an account holder. Basically, it's a list of accounts stored in the Rsk3 Gs library. But next to the accounts, there's also Rsk3.providers. And it's connect to a few external providers. So what does provider mean? This architecture is very similar to Web3 JS, which I think is very well designed, very, very well architected. The providers are plugins that will help to make any functionality happen. And by having external and individual plugins providers, you can switch from one method to another very easily by plug it out and plug it in again. This architecture I liked very much. Let me give you an example. So if you look at the providers on the right, is called WebSocket provider. Those two are both network transaction protocols. So it's just different ways of getting data from internet, right? By plugging in the HTTP provider, you can make a request to blockchain via HTTP request. But if you want to switch, maybe next day you feel like HTTP is too slow, you want something faster, then you change one line of code or 2 lines. You define the provider and then you plug it in. So let's say the next day you want some WebSocket provider, like WebSocket transaction. Then you can create a WebSocket provider in your code and assign it to Rsk3 providers. So just plug in and plug out and plug in. You get a new provider. You can make different network transactions through internet. So that's what providers do. And the last one, HD wallet provider, is the method to generate a wallet. This is the most commonly used one. Like I would say 95% of time people are using this one. But also if you have a different way of creating a wallet, of course, if you're getting more familiar with blockchain, you can plug this out and create a new one and plug it in. So by having this neat architecture, it's very easy for the Rsk3 Gs library to work with different external service provider. So we mimic the structure from Web3.js, and we liked it very, very much. So far it's working great. It's very straightforward and it's very simple. When you actually get to this part, you will like it. Yep, that's the architecture part. Now I think, let me check the chat. Now I think we're ready for some actual codings. Okay, I put together a few demo, it's real piece of code in this slides, in this presentation, to give you a good example of how to interact with the Rsk3 Gs library. First of all, let's look at the first two lines of this code. The first line, of course, import a JS library. If you have, if you any programming, like you have to import an external library in the beginning. That's just normal. The first line, import the library. The second line, it's very important. It instantiates the Rsk3 Gs library. So it creates an instance of the class. I use the ES6 class syntax because it's just more modern and similar to other language. So the second line, creating the instance, also putting a URL into the constructor. That URL is our RSK testnet public endpoint. So you can find it on our public resource. It's mostly commonly used testnet public endpoint. So putting that into constructor actually create an HTTP provider we mentioned in the last page. So what it does, it's just one line of code, but what it does is that it takes the URL, create the HTTP provider, and plug it in to Rsk3 Js library. So we did three things in that one line. Now, after 2 lines, the library is ready to use. Let's look at the third line, block number. So as you know that the blockchain has block height, maybe I should name it to block height. But with the one line await Rsk3 get block number, you can get the block height of current network, either testnet or mainnet. It's just as simple as that. That's blockchain information. The next line, let's look at your information. For example, you have a blockchain wallet. You have a public address that you want to get the balance of it. Now you can, with the next line, constant balance equal to await Rsk3 get balance address. So with this line, you will receive a big number, a very, very big number, normally a very, very big number in response. So the reason for that is that it's returned in the unit of weight, which so 1 R-BTC is 10 to 18 of weight. So you will get a very, very big number. But don't worry, in the utility function in rsk.utils, we have the functionality. We have the method for you to convert that into R-BTC. So basically, this balance equals to 2 R-BTC. With the conversion, you can see that, okay, my wallet has a balance of 2 R-BTC. Yeah, that's the balance line. The next line is about gas. Gas is the most confusing part for non-blockchain developers, in my opinion. Many people ask, what is gas? Like, what's gas used for? It is used exactly as the same gas when you drive a car. Like, if you need to drive a car, you need a fuel. You go to a gas station, you need to get 10 gallons of gas. You need to think of two things. First is 10 gallon. You want a 10 gallon of gas. The other is how much is it per gallon, right? How much you're paying is the multiplication, the multiply of how many gallons times price per gallon. So it's the same. Gas is the same. Actually, here we're this line, this get gas estimate line, is getting you how much per gallon, like how many dollars, maybe how many pesos per gallon. This number is the price. Then you can, when you make a transaction, you can tell the blockchain saying, okay, I want 10 gallon of this gas, so it will be 10 times this number. Then the result is your gas fee. The last line of this page is the utility function I have mentioned. Basically, this is address function is to check if the user input is the correct RBTC address. It's just very handy. Like, for example, if you're building a dApp and you're asking people to type in their, like, copy pasting their wallet address, this method will be very handy for you to check the validity of the address. Okay, I see we have a question here. Let me see what network support wallet is. Permission network they have. Hey, Gullermore, right now our wallet supports RSK Rootstock blockchain, testnet, and mainnet, and Bitcoin blockchain, testnet, and mainnet. So 4 networks for now. Okay, that's the so that's the non-wallet operation demo. So non-wallet operation. Let's take a look at next page. The next page gets a little more complicated because it interacts with the wallet. What does it mean? Is that it's sending transaction, and you are sending money from your funds. It touches your funds. So let's take a look at the code. The first two lines of code are the same. Instantiate, import the library, create an instance, and the next, if you look at the definition of a public key, private key to address, those I removed. So if you're writing a program, you will type in your own values to those lines, but be careful because those cannot go onto any server. It's just your local, like, dev box program, because you don't want to leak your private key to the internet. And next few lines, I'll just skip them real quick because I'll go back. Probably if we have time, I'll go back to these 5 lines. Basically, if you're looking at the first line of the 5, it's the account info. That's what I mean, the account holder. The Rsk3 Gs library convert your private key to an account instance in the Rsk3 Gs instance. So basically, you have a key. It turns into an account object in the library. And next time you use it, you just calling the account info directly. It's just encapsulation of the object. And then you get a chain ID, gas price, and you decide how many gas you want to use. Oh, my bad. The estimate gas is to estimate how many gallons of gas you need to use. The gas price is to get the gas price. So you get all those information. And now you are ready to create this transaction. So if you look at the bottom of this page, I created a raw transaction object which contains all the information. It contains from address. It contains to address. It contains the value you want to send out. This is the money you want to send out. Like if you're going to send $10 to somebody else, the value is the place you put it. We'll just skip the rest. Let's see if we have time to come back. Okay, so this page, you created a transaction, but you're not sending it yet. You don't send it until you sign the transaction. So next page, we're going to check out how to sign the transaction. Okay. Let's look at the signing. The first line of code is still like adding more information to the raw transaction. The second line, the signed transaction equal to await account info signed transaction. This is the line. This is where the magic happened, and this is the most important line of code in all, like among all three pages, because this line of code, once the signature is generated and sent to internet, your money is gone. If you're sending $10, your $10 is gone. If you're sending $10 but you put $100 here, your $100 is gone. So always double check this line. The signed transaction take two input. First is your raw transaction, the transaction object that you created. Second is your private key. I'm not sure if probably you can skip the private key because it's already imported. Let's say the most important is the raw transaction right now. It signs on your transaction and generate a sign hash, the signature. And you take the signature and you call rsk3 send sign transaction, the purple one, the purple function name, and you shovel in sign transaction into the input parameter, and then it's sent out. The send sign transaction will interact with the internet. It will send out the request to RSK public endpoint. So once you call this line, your transaction is out. And what do you do next? You just wait. You wait for it to come back. So let's look at the few ons. The dot on. The dot on tells you when the first dot on transaction hash tell you when the rootstock object get your request. That's very fast. That should come in 1 second. So you send it out, it comes back. It gets your request. But your request is not confirmed until 30 seconds later. It's almost 30 seconds for a rootstock. So it's not confirmed until 30 seconds later. So 30 seconds later, you get notified by the second on, the on confirmation. So in that notification, in the console log, you can see that it gets a confirmation number and it gives you a receipt. The receipt has a lot of things in that. The receipt has all the information for the blockchain confirmation, the blockchain transaction, like who do you send to, where is it sent from, how much gas fee you pay, and if you have any data, for example, if you have any message shoveled into the data, you can see the data over there. And the last on is error. So what if anything happens, if any error occurs, this on error console log will output the error. It can happen anytime, maybe after 1 second, maybe after 30 seconds. But if there's any error, that line of code will trigger. So this page, we learn how to sign a transaction and send out the signed transaction. This is where you make this transaction happen. This is where you send your money out. So this page is important. You can skip the previous one, but make sure to pay attention to this page. Okay, after this last page I want to put here because many dApp developers, they do not need to save a private key in the code and sign the transaction with the private key. Because we have a thing called a Metamask Wallet, which is a Chrome plugin for users playing the dApp to store their wallet over there. So they have their wallet over there, but we have our Rsk3 Gs library in our web application. Let's say it's a web application. Let's say it's a trivial game. It's trivial game. It's a web application. So how do we interact? How do we ask a user to send money to us, right? If you want to play a trivial, for example, if you want to play, you spend $1 playing, the user can get maybe $2 in return or $0 if they lose. Right? They need to send us the $1 first. How does that happen? So this page, I put together a demo for MetaMask. Let's go over it. So the first few lines is still the same. You create an instance of the Rsk3. The second line, set provider. Now the provider, as I mentioned before, is not the account is not a imported account by your private key. It's an account managed by MetaMask plugin. The MetaMask plugin is on the user's computer, which you don't have access to. So by setting window.ethereum, set provider window.ethereum, you get talk to the user's wallet, saving the MetaMask. So you get to talk to it, but not to give you money yet, right? And let's keep looking at the code. The first line, window.ethereum.enable .then. So once you enter this then, you are able to interact with the wallet. Let me put it in a better way. You are able to get access to the wallet of users. So because let's see this line, rsk3.default account equal to from address. Now you get the user's wallet address. You get the address. What do you need the address for? You are creating a transaction object for them because you want the money sent from their address to yours. The from address is their address. Now you have it. You have their address as from. You have your address as to. If you can make the transaction, you can create the transaction. You can send money from the from address to the to address. So you get the money. of course, the same as previous page. We need a gas. We need a chain ID. We need a estimate gas. So we get all those information. I just skip those lines of code here. And we go to the last then. The last then, there's a mistake. It's still web3.eth. Okay, here's a good demo of why we don't use web3. What do we have done to make Rsk3 easier? So in web3, everything is web3 dot something, web3 dot accounts, web3 dot eth, web3 dot IBAN. So it's very long. The calling of this method is very long. Like you need 2 dots, sometimes 4. If you go to personal.wallets, there are 4 parts, 3 dots. It's just very confusing. Like I don't know the history of building of the Rsk3 Gs library, but it's just confusing for user to use. Also, it's so long to type, right? So when we make the Rsk3 library, well, we made a decision that okay, we need to make it shorter. We just use 1 dot, 2 parts to do the job that Web3 has done, right? Like this is an example. This is old code. It's still Web3, but in Rsk3, you just do Rsk3 dot send a transaction, and it's sent. So it's more like a shortcut of the function call. And the same, like the on is the same. You get a recipient, you get a recipient confirmation, and you get error code whenever that happens. Yep. So this is the demo of how to use Metamask. I think this is maybe more important to many dApp developers. Also, we have demo code in the GitHub, so you don't need to worry about like forgetting anything from the demo. We have the code for you, so you can just copy paste into your application. Yeah, I think that's it. That's all the content of today's webinar. Yeah, of course, we will share the demo. Yeah, this is the do you have any questions page. I guess let's go back to Fran.
Yeah, thank you so much, Chris, for this demo and this this whole presentation about using the code and something else. Well, here I have one question that comes from Guillermo. That is, well, you can explain it to all. He's asking what networks are supported by the wallet, permission networks like Hyperledger, Besu, or RIF, consensus nodes. Are those supported?
Those 2 are not supported, unfortunately. We currently support Bitcoin network and Rootstock network, both testnet and mainnet. So we have 4 networks. Yeah, but good. Thanks for the input. We can add them to the feature plan, to the backlog. Yeah, but I need to be honest, I need to take a look at, do some research on those 2 networks. Yeah, but thanks for the question.
Great. So if anybody has another question, please write it. We will be staying here. If not, we will closing this webinar, and afterwards, as I told you at the beginning, it's being recorded and we'll upload it to our YouTube channel. So well, Chris, I copied this question and I will send it to you. So guys, take your time.
Yeah, please also give me feedback how well I'm doing, like 1 to 5, right? So I can improve.
Yes, that's very, very helpful, I think. And also, well, something that we didn't tell you, but it's also, well, good news and it's very useful, is that our developers channel, we have an open chat, open 24 hours, where our developers will be answering to you, besides our channel at GitHub and Gitter. So, well, here I'll type it down so you can chat with us, developers.ch www.rsk.co. You can chat with us during our 24 hours. As you know, we are a global organization, so whenever people are sleeping, our ones are working. So we have, well, Chris actually, well, he's in the West Coast, I'm in Argentina. We also have people working in Asia, in Africa, in Europe. And so we are pretty much in all the continents, and we also have some of our team are in Oceania, in New Zealand. So, well, thank you so much for your time. I'm not seeing any questions. So, well, there you can see, you can write Chris at ioblabs.org, and his Twitter is chrislee2046.
Yes. Thanks, Brian. Thanks for having me here.
Thank you, Chris. Well, bye-bye to all. Have a good night. And a good day, of course, a good weekend.
Oh, I see Pablo's, yeah. Yeah, like the text a little smaller. Yeah, my bad. Should make it bigger.